Hi guys, welcome again, and this video is based on our review questions, and I'm going to work on the regression analysis question. So we have a number of questions for regression analysis, and I'm going to start with the first one, which says consider the linear equation, which is y equals to 12 plus 15x, and this is y estimate. So the question says, what is y-intercept and what is slope? And also, what is the dependent variable and independent variable? You can see that this is y-intercept, and 15 is the slope of x, and then dependent variable is y, and independent variable is x. So remember, we said that if we have two variables y and x, and we know that y depends on x to occur, so y is a function of x, and we have etc, or we call it the error term. So then we can say y equals 2. We can use we're going to show y-intercept, and that can be written as a plus, or we can write bo plus, so either way, but that is y-intercept, and then b1 is a slope of this value x, but we have to we have to add e, the error term. So in this case, we have y, and then y is observed. This y-intercept plus the slope of x times x is y estimate, and e is residual. So let me write here, y is observed, and then let me do this. Y, so I'm going to skip and write here is observed. So we have values for y, and then we have y estimate, let me do this, bo plus b1x is what we call y estimate, and then e is residual, and therefore y observed equals to y estimate plus residual. Okay, so that's more explanation about this first question, and I may ask you some questions on this as well. So let's look at the second question. It says, recently the annual number of driver deaths per 100,000 for the selected age groups was as follows. And so here we have age, and we have values, and also we have number of drivers deaths, and we have values as well. So it says if age is independent variable. So what is the dependent variable? Dependent variable is the number of drivers death. Then we are supposed to calculate the least squares line, or best fit. This means that we need to run regression and come up with our estimated values. If you can remember, in class we compared estimated values with observed values, and we could identify residuals. So the least square line is the estimations, and we try to see how it can fit to the observed values. And remember, in class we mentioned that we need to reduce the error term as much as possible. and that one can be identified by the R squared. So we need to do regression. We have to do regression analysis in this case by using Excel. So let's work on this side. Our calculations will base on what we said, that depth is a function of age, meaning that the number of deaths depend on the age. So we can write our regression model, and this one can be written as deaths equals 2. So we should write BO or A plus B1H, and then plus error term. We can do also estimates. So our estimated model will be death estimate equals to BO plus B1X, and in this case we don't include the error term. You should remember about that. So we need to hypothesize this B1 or the slope, and so we can say null hypothesis states that slope is 0, no slope, and this is based of 95 confidence level. And then alternative hypothesis, which is HA, so the slope is not equal to 0. It should be a significant, the slope is significant, and therefore it shows that deaths depend on age. And we're going to give probability, which is the p-value less or equal to significance level, which is 5%. Significance level, yeah. So it's important to show the hypothesis in this case, and that's why we learn about hypothesis. Let me click here. Let me highlight that. So the next thing is to run regression, and you can remember how to do this. So just click on the data to see if you have data analysis. If you don't have that, you can go to File, click on Options, Add-ins, click Go, and then make sure that you're going to check this box, Analysis Toolpack, and click OK. So if you're using Mac, Mac has this ribbon, and also there is another ribbon on the top, and find Tools. Then click on the Tools, scroll down to Excel Add-ins, and then you will be able to select or check the box for data analysis, and then come back and click on the data, and so open data analysis, select regression, click OK. So we need to input Y range, and Y is the dependent variable, and so that is our dependent variable. Oh, sorry about that. That should go to Y. So Y is our dependent variable, and X range will be the independent variable. Make sure that labels are selected, or you check this box because we included the age, And then we need to define where we want our output to be. So click on the output and then click here. Make sure that you are not going to have your output on top of what we have. So I'm going to select output to be here on the other side. So leave confidence level to 95% confidence, which we have here, confidence level. So we have output range and then we need residuals. So you can click OK. And so you have your results. And the next question is to interpret your results. So we will start with multiple R, meaning that it is the correlation between the estimated values and observed values. So these are observed values because we have error term included, and this is our estimated value. So is there a correlation between the estimated model and observed values? So that's what we are going to see. Now, the correlation here is not really very, very strong, but it is above 50%. We would like to have more correlation, but I would say correlation is good. So let's see R squared. R squared in this case is very small. R squared is 33% explained. So that means 67% is unexplained. 67% unexplained. And this is not good because X can explain just a little of Y, meaning that there are some other factors that could explain more about death, and it's not about the age. So age does not significantly explain deaths. So look at the adjusted R squared. The adjusted R squared is 16%, which actually is a significant adjustment to the R squared. So we could go with this one, 16% adjusted R squared. So already we can see that our results may have some issues. Now let's come down and let's look at the coefficients. Let me highlight these coefficients. Remember, this is BO according to our equation here. So BO, which is y-intercept, is this value here. And BI, which is the slope for age, is actually this one. So we have slope and also we have y-intercept. Now let's look at the p-value, which is important. So you can see that p-value, let me write here, p-value is greater than significance level. If you look here, the p-value should be less or equal to 5% significance level. But this p-value is not, is actually greater than the significance level. And if the p-value is greater than the significance level, then that means age is not significant, or this slope is not significant. And if we can go back to the hypothesis, then it means that there is no slope. Although we have some slope, but this slope is not significant. It's almost 0. So we cannot reject the null hypothesis. We fail to reject the null hypothesis, meaning that age cannot explain number of deaths because the slope is almost 0. So when you change age, does not necessarily relate to the change in the number of deaths. So that is one. And you can see here we have negative, meaning that there could be some inverse relationship between age and number of deaths. So if this was significant, we could say that the younger the person is, the more risky they are than the old people. So the older you become, the less the accident, and the opposite is true. However, we cannot make such judgment because p-value shows that age is not really significant. So our conclusion is age cannot explain fully the number of deaths. So that is the answer. If age could explain the number of deaths, and let's say if the p-value was less or equal to significance level, then all we could do was to rewrite our model, including these coefficients. And so, because we have a question, we have to predict the number of deaths people aged 40. Although this equation is not significant, we're going to respond to that question. So I'll show you how we can respond to that. Now we have to rewrite our estimated model. Deaths estimate equals 2. Now we are going to put y-intercept, which is 35.58 plus, so this is positive, this is positive, and the other one is negative. So we are going to minus 0.192, and that will be times age. Let me take this and move it here. So there's so it says deaths estimate equals to 35.58 minus 0.192. So as I said, if this was accurate, if this was significant, then we were supposed to write our model like this. And then we could respond to the question that says, predict the number of deaths people aged 40. So the age is 40, so we're gonna write here that's equal to 35.58 minus 0.192, and this one will be times 40. And so in this case you can do the math. So let me put equal sign here and type 35.58 minus 0.192 times 40. So let's see what is the answer. So if we consider the age of 40, that will be 27.9. That's the prediction we could make. Let's see if we have that age here. Oh, so we don't have 40, but we have 44.5, and the estimated all the number of deaths for this group is 20. And we made estimation for the number of deaths based on our regression equation. And so age we considered 40, and so we get 27.9. So again, you can see that we have these estimated values and the residuals. So these estimated values can be compared to observed values. And here are the observed values. So we have estimated number of deaths, and we could compare with this actual deaths, and then we'll see residuals. So Excel already defined residuals. They found residuals for us with the estimations, and that's what we have here. So you can see these residuals. But we can say that since R squared is too small, then this may not give us the real answers. But anyways, we have answered that particular question. And if you have that kind of question in your exam, you should see how to do it. Now next, let's look at this summary output. This one was actually provided as a question. So I may give you outcome of the regression like this and ask you to describe the outcomes of these results where salary is a dependent variable. Now, if salary is dependent variable, you can see that we have these other variables, which are years of experience, years employed, years of education, gender, department, and number supervised. And so it says, describe the outcomes of these results where salary is a dependent variable. Now, with these results, the first thing you're going to do is describe the multiple R. And we can see that we have strong multiple R. We have strong correlation between estimated model and the observed data. Correlation is close to 1, so it is very strong correlation. How about R squared? R squared also explains about 82% of the observed data. So we can see how much we have minimized error term. And adjusted R squared is not really different from the R squared, so there is no too much adjustments. So we have good R squared, or we're going to say R squared explains 82%, and only 18%, which is not explained. We have strong correlation, and let's come down to see what happens with our coefficients. So remember always that our coefficients will address the y-intercept and then the slope of each particular variable. So in this case, we have 1, 2, 3, 4, 5, 6. We have 6 variables. And therefore, so we are going to see which ones are significant and which ones are not significant. And that's for the second question. Which of these variables are significant and which are not significant. So we don't care about these numbers that are presented here as their slopes, but all we care for are the p-values. And we're not considering p-value for the y-intercept. So years of previous experience is negative in this case, meaning that when you have experience, then your salary goes down, and the opposite is true. But that is not really true, because look at the p-value, which is greater than 0.05. So years of previous experience cannot explain salary. You may have some slopes, but they are not significant. They don't relate to your income. So income or salary does not depend on the years of experience. Let's go to the second question, years employed. So years employed has this slope, meaning that a year of staying at work. So 1 year at work will add you $621, let's say dollars. That's how the slope is. So do you think this amount is significant? So we don't care about the amount mentioned here, but we are looking at the probability value. You can see that we have E to 5. So that means you're going to write 0.4015. So probability is actually less than 0.05. It is very small probability. And let's look at years of education. We have also this value, meaning that if you go for 1 year, if you take 1 year of education, your salary will increase by this amount. We cannot compare with the amount which we get for the years employed, because they are both independent, and we can explain one on its own without any interference with the other. So years of education here, we have this value, which is the slope. Let's see the p-value. P-value also has E equals to E5, meaning that we have 0.406. That also is smaller than significance level. So this amount is significant. How about gender? Gender has got minus, and it's 1,654. The amount is bigger than this one and the other one over there, but is this amount significant? Meaning that your gender will reduce 1,654. So we need to prove by p-value. P-value is greater than the significance level, and so this slope is not significant. It doesn't relate to your salary. So gender is not your salary does not depend on your gender, because p-value shows that this amount is not significant. Department as well has got a probability value which is less than 0.05. So we can say that this amount is actually significant. Number supervised, we have 134 as our slope, but the p-value is greater than significance level. So number supervised is not significant. So here we have this question: which ones are not significant? So we have number supervised, we have gender, and also we have years of previous experience. Which variables are significant? They are years employed, years of education, and department. So in your exam, I may give you similar kind of, or I can give you results and ask you to describe the results, and probably another question which will require you to run regression as we did for this particular question here. So I think that's all with the regression analysis, and everything is clear, and we have addressed what actually we discussed in class. But you should remember that this is multiple regression analysis where we have more than one independent variable, and this one here is simple linear regression or bivariate regression analysis, because we are focusing on only one independent variable, which is age. Thank you so much.